Hello. So I'm Brian Curtin. Nice. All right. Yeah. So I'm Brian. Here to talk about Python 3.3. I am one of the core developers of CPython. Do a bunch of other PSF stuff. Work for Canonical. At Canonical, I'm doing a bunch of Python 3 stuff there. So, given that I work on it on my free time and at work, and we just had a release, I figured I would kind of say what's up, what's going on. Anyone here use Python 3 for anything? Exactly what I thought. All right, yes, more than one. All right, cool. Still kind of taking off. It's been a couple years, but Python 3.3 is really cool release. A lot of good stuff, faster, a lot of improvements, a lot of new stuff, and that's what we're going to talk about here. I actually did a kind of a preview of some of this stuff sometime in the spring. It was whatever we were at Groupon. Not so much a rehash. There's a couple of things that I recovered, but this is listed as a 1 hour talk. I don't think I'll talk for an hour, but we'll see what happens. So anyways, fancy little thing here. So yeah, a couple weeks ago, just about 2 weeks ago, on the 29th, we released Python 3.3. It's on our regular schedule of a new feature release every 18 months. 80 committers were involved in it, over 120 external contributors, wrote patches, reported bugs, and that's just from the acknowledgements file. A lot of people submitted a lot more bugs, so it's much more than 120. That's just people who submitted significant code patches. I'll talk about PEPs in a minute if you know what they are, but 12 PEPs were implemented, which I think is probably one of the bigger, except for Python 3.0, it's probably one of the bigger releases in terms of new, big new stuff they needed to PEP, and almost 7,000 commits went into it. I didn't really compare that to other previous releases, but from what I remember, it's kind of a high amount. So a lot of stuff going on, a lot of people contributing to make the latest Python. So why are we doing this? Because Python 2.7 is done. A little bit harsh because everyone here is probably using 2.7 or 2.6 or 2.5, but in terms of the development of Python, 2.7 is the end of the road. Bug fixes are going to keep going for a while. Security fixes for a long time after that. So it's not really done. It's not really over or dead. It'll live for a long time. But active development in terms of features is all on Python 3. So it's the future. I've been using it. I used to work at Trading Technologies. We used 3.1 for a while. Left with Canonical, do 3 stuff as well. So it's been the future for me in the past as well. But if that makes sense. So since no one here is using it, you're not obviously inside these numbers. But looking through the web stats on python.org, the first weekend alone, 43,000 people downloaded the Windows installers. That's the only kind of platform we have reliable numbers for, because if you're using a Mac, you get Python from whatever. Not many people go to python.org and install the new DMG installer or whatever. Or if you're on a Linux machine, not many people are downloading the tarballs. You'll eventually pick it up from your distro. Windows is the only place you have to go to get it. So kind of the only indication we have of things going on. So 43,000 the first weekend, that was 2 weeks ago. Through October, it's over 200,000. Averages out to about 20,000 people a day downloading Python 3.3 for Windows again. It's kind of cool. It's kind of cool to realize how widely it's used, especially on Windows. So what kind of makes up these big releases? In terms of like the bigger features and bigger changes are kind of come from PEPs, Python enhancement proposals. Anyone familiar or not familiar with these? It's basically, anything that's potentially controversial or changing the language or changing really big scale changes typically go through this PEP process. It's basically you write up this big document and it has an abstract and it has rationale and it has a bunch of different stuff and it's debated by a bunch of people and figure out there's a what do we call them? Oh, like PEP dictators that end up being the approver for this to make sure everyone's on board with it and everything's been fleshed out. And like I said before, we had 12 of them approved and implemented for 3.3. So I'm going to just cover a couple of the bigger ones, and at the end I'll list a bunch of other ones. Who here is familiar with virtual env? Hopefully everyone. Okay, mostly everyone. So if you're familiar with it, I don't have to cover a whole lot about it, but virtual env is basically now in the Python standard library in 3.3. When I go through these, I kind of do like a why and a how. If you've ever looked into virtual env, it does a lot of crazy stuff. Carl Meyer, who is the current maintainer of virtual env, did a talk at ThoughtWorks maybe a year and a half, 2 years ago, about some of this wild stuff it does to make it the powerful tool it is. Putting it inside the standard library removes a lot of that crazy complexity, and the fact that virtual env is unanimously kind of the best tool around for its job, and a lot of people use it, and it's very mature, makes it a perfect tool to go in the standard library. As a lot of people say, things go in the standard library of Python when they're dead, when everything's figured out, API is not changing, it's a popular tool. So made perfect sense. It was not very much debate about this one. It was just kind of a big change. So we now have the venv script, or it's actually a module that you just run as you would virtual env. There is also a pyenv script that's now in the user bin to do the same thing. So I'm not even going to run the example because you've already seen virtual env, pretty much everyone in here. But yeah, you're just the same as you would anything else. Give your environment and builds that up for you. Another cool PEP that was approved had been a long time coming. I think this was, I can't remember how many years this was started, but I believe it predated Python 3 and it had been ported across, and finally came up that it was time to implement the what's called the yield from PEP. Everyone's familiar with generators, so the yield statement. This is kind of pretty cool because it allows, so this PEP allows you to yield from another generator. So you can refactor things into other generators and have things nicely talk to each other. You can also return from a generator, and I only know some of the basics of this, so I kind of just wrote they're powerful. A lot of people who are much smarter than me have said, yeah, this is the best PEP ever. It's awesome. So I'm going to trust them because I trust them. And basically you just yield from a subgenerator. So I do have some simple little examples here. What is it? Let's see. Oh, that looks great. I normally do all these dark colors, but you can't read them. I hate this. Let me just close this. Or can you read this? No, you can't read that. This is why live coding demos typically don't get accepted to PyCon.
Can you change the background to black?
That's, yeah, I'm opening this one right now. Is that better?
Yeah.
There we go. All right, so it actually did work. So it's kind of a very simple little example, but you have, so the main thing here is we're in func, and then we want to get these numbers out of subfunc. So I would have to iterate over what I get back from subfunc and then yield it back. Not very hard. Pretty easy to explain, I think. It's much easier now with this. So we have, rather than, let me bump that up again. So now we can just say from our subfunc, which again is kind of a simple thing, it just yields from a list. You could even refactor this out and just put this list straight in there, but had to make something out of it. You could say yield from something that also yields to you, and just makes it a lot cleaner. The other thing is in the subfunc, I now have a return, which gets set so my x equals yield from x is going to be my foo bar, and it'll yield the numbers from the list. So if I just, very simply, it just prints out those numbers and prints that out. If I do, so let me go back to the before. So if I was to put in here that return in Python 2, this is a syntax error. Oh, let's see. Yeah, so you can't have the return. And the PEP 380 adds the handling of the return to send it back as the return value of the yield from. And again, I'm going to try to learn more about this yield from stuff because a lot of people have said it's really cool stuff. So hopefully I can come back in a month or two and actually have something worthwhile to talk about here for this specific feature. But it's definitely worth looking into if you do a lot of generator stuff. Let's see. So that's 380. Another PEP, and this is implementation is very small, but PEP 414 reintroduces explicit Unicode literals, the little U prefix to a string, to ease porting. This kind of came out of a lot of the web framework authors. It was spearheaded by Armin, I don't know how you say his last name, Roniker, I think, the guy who created Flask. When PEP 3333 came out, one of the WSGI PEPs, a lot of people started looking harder into porting to Python 3, especially on the web side, and their major stumbling block was the Unicode literals because it's a syntax error in 3.0, 3.1, and 3.2 to have the leading U prefix. So you have to run everything through 2 to 3 or manually remove all that stuff. The leading U is kind of a meaningless removal, and it makes the changes you have to do are much bigger, and overall it's a pretty small thing. So it was very easily accepted to bring back the U support. This example is pretty quick, but so something like this. We have two print functions that print out jalapeno with Unicode inside. One of them's got the leading U, one of them doesn't. On Python 2 this will work. On 3.2 it will not work. In Python 3.3 it will work. Not going to run it because it's just going to print out jalapeno twice. Or it'll be a syntax error on 3.2. But if you're porting from, at this point if you're going to port to Python 3, you're going to port to 3.3. So it makes sense now. It's just a much more seamless transition from 2 to 3 after we added this. Or re-added it. It was already in there, but was removed. Another thing, if you've ever looked into, I think this actually went into 2.7 as well, chained exceptions in exception context. If you catch an exception and raise a different exception, you see the previous exception as well, so you can see two different tracebacks. Very nifty feature. Needed to give it a little bit of context in itself. So this PEP 3134 introduced this exception chaining. So you see, it's when you raise one exception, when you're handling another one, you get these. What do you get? PEP. What is this? 409. Yeah, so you see here, if I raise an attribute error, something, and then I catch it, and then I raise this type error, when I run this in 2.7, let me see. Let me run in 3. Yeah, so we see the original attribute error that I raised, and then the one that I actually wanted to really give you was the type error. But I see during the handling the above exception, another one. It makes it look like it's kind of unintentional. It looks kind of sloppy. It's just saying you did one thing, something else just happened to occur. So it was changed in 3.3 that you could now say you're raising one exception from another. So if I run this in 3.3, now it says the above exception was the direct cause of that exception. And when you handle them, each exception now has a double under causes, or cause. So you could tell when you're handling something else what spun that off to happen. And if you want to get rid of this kind of double exception thing, you can now raise it from none. So you're saying that we're going to skip the attribute error and we're just going to give the type error and forget about everything else. Make that easier to see. So now if I do that, looks like familiar to everyone else, just a regular little type error. Forget the context. Yeah, so if you raise from something else, you give it a cause. If you don't, it's just kind of hidden. This is one that I covered at the previous time I talked about this in the spring, PEP 3151. We're kind of restructuring the OS and I/O exception hierarchy because there are a lot of places where under the hood implementation is kind of leaked out. One of the bigger examples is files that don't exist. If you try to open a file that doesn't exist, you get an I/O error. In OS remove, if you do it, you get a OS error, and then you're dealing with something that doesn't exist, but you have to handle very different exceptions. Really, there should just be a file not found exception, which is what it became. A lot of other places, especially on the Windows side, Windows error you got to handle, but Windows error only exists on Windows. So if you're doing anything cross-platform, you have to check that Windows error exists as a name, then potentially handle it. Gets kind of messy. So everything was coalesced under OS error now. Kind of small list, but you have stuff like blocking I/O error, file exists error, file not found. Is a directory. Permission error rather than having I/O or OS depending on what's happening or what's called under the hood. And so that's some of the more prominent PEPs. There are a bunch of other ones. Python Launcher for Windows is a pretty cool one. 397. It adds a launcher that can find either a Python 2 or a Python 3 or any other Python you have in your system, so you don't have to. One, it removes the need to have Python on your path, which is kind of cool because now you can just have it's in a way it's kind of a shebang processor for Windows. It's not intended to be exposed that way, but that's basically what it is. Along with that, on Windows, this is not a PEP, but I added the ability to add Python to the path on Windows in the installer. I don't know a lot about namespace packages, so I didn't cover them. The flexible string representation I'll talk about at the very end. A bunch of different clocks, like monotonic clocks and whatnot, were added. 412, the key sharing dictionary, is also pretty cool. I talk about it at the end as well. But as always, a bunch of new modules were added. Who's familiar with mocking libraries? Probably everyone. Probably everyone knows a ton of them because there are a lot of them. Mock, the very simply named library, is kind of one of the better known ones. It kind of gets around as one of the better implementations. It was created by Michael Ford, who is the maintainer of unit test. So it was added as unit test.mock. Hopefully that kind of, as you see, there's 1.5 million mock libraries. Not really, but hopefully that kind of answers the question of which one you should use. Now it's in the standard library. Simple little example for that. Anyone not familiar with why you would use mocks in testing? So, one hand. Basically, if you ever want to isolate external resources, so you had a database or the internet or something that you can't always control and it's too heavyweight. If you had some big database, you don't want to create a new instance of it all the time for every test. You can mock it out and just make a kind of a fake version of it so it's easier to test, and you just test the interface and don't worry about the fact that it's not a real database. So in this, you can see that. So I have a very simple test suite that has one test, and it just tests that os.lister returns 2 files that I say should be there, and so it's decorated with. You see that all right? Yeah. So unit-test.mock.patch. I'm going to replace os.lister with a function that emulates it. So I just give back, when you call my fake lister, it gives back the 2 fake files, and I just test it through there. And that's one of the simpler cases. You could do a lot more powerful stuff with it. Didn't want to go sidetrack on talk about mock forever, but it's pretty cool. If you haven't looked into it, check it out. It will make your tests better. Yeah. So another one that was added, the IP address module. This was added as the first kind of provisional library to the standard library. Typically, as I mentioned before, where things go to die, we kind of loosen that up a little bit for widely used libraries that are trying to get in the hands of other people and have the community kind of help solidify it. So IP address apparently is used, not by me, but apparently used pretty widely for anytime you got to deal with IP addresses. So it was added. It's not totally solid if in the future there could be some API changes, whereas typically in Python, backwards compatibility, save for across super major versions like 2 and 3, between say 3.2 and 3.3, backwards compatibility is of utmost importance. We kind of loosen that for what we're going to call these provisional libraries. So IP address could change if we find out when people are using it. It has all kinds of crazy stuff.
Is it doing IPv6 anyway?
Yeah, it can handle. So it'll handle anything. So in the example I have, it's really small because it's on the bottom. So if you give a string that's an IPv6 address, and it's 4 or 6, it'll parse strings and figure out if they're valid IP addresses. Then you can create a network. So in the example I have, which is very small at the bottom, but basically I just iterate over an IPv4 network, 192.0.2.0/28, and that just iterates IP addresses that would be on that network. You can do the same thing with IPv6. Do a lot of other nifty stuff with it. I don't do a whole ton of network-related stuff, so I didn't look too much into it for examples. But yeah, you can validate stuff, test stuff, iterate over whatever, and yeah. Any question about that? I don't have many answers for it, but it was added. Wrapper for LZMA compression was added, kind of like bzip, gzip. It's a new fast and efficient compression. It's very simple. It follows the same interface as the bzip library. Fault handler is pretty cool. It is a kind of a crash debugging tool implemented by Victor Stinner. Let's see. So I just have this very simple 2-line example. This would cause a segmentation fault. So if I run this, it's off the bottom of the screen, but yeah, there you go. I see that Python quit. Let me move this. Yeah, so this is the Apple shipped 2.7, so they have their problem reporting thing. If I just do this with Python 3.2, which I've built myself, you don't see the fancy Apple thing, but you just see segmentation fault. If I do this with Python 3.3, and there's a new -x command line, or you could set, so this is to enable fault handler, and there's also environment variable. You could also import it from in the code. But now if I run this, it tells me much more information. Current thread, it gives me an actual traceback of what caused the segmentation fault. It says it's my second line in example.py, which is where I did my string at 0. So you can also write this stuff out. It'll also handle, let me go back here. Didn't write down. You could write a lot of cool stuff with this to handle like deadlock detection and dump tracebacks by time. I have an addition to this I don't know when it's going to be in, but for Windows to write mini dump files for debugging, which would be cool. As always, people wonder, okay, I changed all this crap about IP addresses, and not going to use that. Performance always comes up. No, the GIL is not removed. No GIL changes, but the decimal library now has a C accelerator, known as C decimal. Integrates the libmp DEC, probably libmp dec or something like that, library for really fast, high precision math stuff. On numerous benchmarks related to like calculating pi and a bunch of other stuff, up to 120 times faster. And these were all verified by very smart people to be accurate, so it is 120 times faster on some things. The lowest increase that it showed was at least 10 times faster on a bunch of database, like Postgres benchmarks. There were also a bunch of memory reductions. So I talked the last time about the flexible string representation. Makes Unicode much more efficient in Python 3.3. It's a lot better than 3.2. It's a little bit better than 2.7. Basically, instead of having 4 bytes per character, if you have some, depending on what your build is, if you're doing just ASCII stuff, it could be 1 byte per character. It kind of figures out whatever the smallest representation it could uses that. The other is pretty cool. The key sharing dictionary. This is now the built-in dictionary. When you have, say, a class called person, we're all people. We all have our own instance. We all have our own name, age, gender, all this kind of stuff. We all have the same keys in all those dictionaries. Rather than each of us having a list of those keys, the hashes of all that, however many people are here, the instances, they're shared. So now, much lower memory use. It's much more efficient. It follows the same API, the same everything. Internally, it's all the same. It does sort a little bit differently, but it's pretty sharp. I don't know a ton about dictionary internals, but I don't have the benchmark numbers on there, but it saves a lot of space, especially, and it's dependent on how many instances you have. But yeah, that is it. A lot quicker than an hour, I think. I hope. Any questions? Anything?
When is Python 3.3 going to have concurrency? Is it possible sometime in the future?
Like, what do you mean?
I don't know. It's just that PyPy is, it's not really clear like when it's going to be ready, and that's well, it does have concurrency. It does have some problems with slowness and. You mean getting rid of the GIL? Yeah, the global interpreter.
If you pay for it, it might happen, but it's a very hard problem to solve. Yeah. PyPy. So PyPy actually has some interesting things going on. It's getting faster all the time. To them, if something is slower on PyPy than it is on Python 2 or 3 or anything like that, they look at that as a bug and it's got to be fixed. So they're very aggressive in their reaction to performance. They're also doing a lot of wild stuff with software transactional memory. They got all kinds of crazy stuff to try to sidestep or remove the GIL on their end. If you're looking for performance, I would highly recommend to check out PyPy. I couldn't tell you if it's production ready. People are using it like crazy. Alex Gaynor, who is formerly a Chicago resident, moved out to California. He has talked here numerous times, is one of the PyPy core developers, and he worked at Quora. And I believe they actually use it in production. He did a bunch of work for them, and they got it set up. And I believe whatever they use Python for there in production is on PyPy. So I think it's ready. I don't, who knows when you can actually stamp it? Because you could say Python 3.3 is not ready or 2.7 is not ready. There's no real stamp of approval besides if it works with your code. So I would, if you're looking at it, check it out, see how it works. Yeah. But as far as like the concurrency and GIL stuff in 3.3, No real activity that I know of for now. It's something we'd like to get rid of. It's just a super hard problem. I don't know if anyone was at the second PyCon in Atlanta. There was an open space about removing the gill. And it was like, oh, he's not here. Dave Beasley was there. It was kind of crazy. It was stuff that all of a sudden it just took off. It's like, wow, that just happened. Had a lot of crazy ideas, but nothing kind of came out of it because it's very hard to do. So who knows?
Is it a hard problem because just to kind of like engineer Python to do that, or just because it's a hard problem in general? Because Java has that. Java has good concurrency and sort of exposure and some other languages.
One of the kind of rules for the change to be accepted is that in removing, so people have removed the gill,
Yeah.
but to have it to be merged, it can't affect single-threaded performance. And to my knowledge, every single attempt at this has decimated single-threaded performance. In the interest of making multi-threaded better. So it's a really hard problem in general, but it's even harder to make it across the board acceptable. Apparently, it's much above my head, at least as far as I've looked into it. But and it's kind of fundamental to Python as it is. Writing C extensions, you don't have to worry about any of that stuff as it is. If we remove the gill, it pushes the problem of managing that stuff onto the users. So removing the gill kind of could potentially change Python greatly. It could make it a hell of a lot faster. It could do a lot more different stuff, but that would certainly be a PEP. It would be a very big one if it was to happen. So, and there's been a number of approaches, and if you remember the Unladen Swallow project, which was sponsored by Google, those guys they got some good speed ups out of what they were able to do, but ultimately they weren't able to remove it. And I don't remember if it was actually the stated goal. I think it was a sub goal of just in general making a more performant interpreter. But yeah, I know some of those guys, they're super sharp guys. Nothing came out of that either. But so actually, correction, a lot of things came out of that, but not removing the gill. Anything else? Cool. Thanks.